Hello again, everybody, and welcome to science class. I'm your host, Mr. Reichler, and today we're going to talk about the Earth. We're going to talk about how the planet Earth moves, and we're going to talk about why we have seasons. So let's get going, shall we? So to begin with, how do we move? Well, you see, to begin with, our planet is constantly in motion. We're spinning around like this, we're going around the sun like this, and the whole solar system is flying through the universe, along with the galaxy. So, every day, our planet, it makes one full turn on its axis. True story. An axis, you might add, is an imaginary line that our planet rotates on. Ooh, look, there's a big boldface underlined word. If you look at your guided note sheet, number 1 has a blank on it, and that blank is axis, A-X-I-S. Write that on down. If you ever get behind during our presentation, you can just hit pause, fill in the blank, and then continue on. So, let's continue on, shall we? If we drew a line from the North Pole to the South Pole, you can see how the planet rotates on that line. This is called the axis, right? And if I put my finger up underneath the planet like that, it would spin on my finger. But there's one problem. Our planet, it doesn't rotate this way. It actually rotates like this. You see, our planet is sitting on its side, kind of. We are turned to an angle of 23 degrees from top center being here. So essentially, we're kind of hanging around. If this is top, this would be 12 o'clock on a clock. We're hanging out somewhere around 1 o'clock as far as our axis goes. That makes sense? Our planet makes one complete rotation on its axis once every 24 hours, or once a day. And this is the reason why we have night and day. One side is facing the sun, the other side is facing away, and spin it goes. Makes sense, right? While our planet is rotating on its axis, it's also moving around the sun. The path that the Earth takes around the sun is called an orbit. See how that works? An orbit is a circular path that one object takes around another object. Now, the moon, for example, is in orbit around the planet Earth. Planet Earth is in orbit around the sun, and so on and so on. It takes the Earth 365 1/4 days, about 6 hours, to make one trip around the sun. We call that's right, Dora, we call that a year. Why do we have seasons? Well, it's not terribly complicated, or is it? You see, as the Earth orbits around the sun, we have our seasons. Now, question, where will we have summer in the northern hemisphere, where we live, right? Would it be there at point A, or there at point B? Point A, far away. Point B, close up. What do you think? Yeah, I agree. Point B, because it's closer to the sun. So, no. We're closer to the sun at point B. How can we be that far away at point A and have summer? Wait, what's going wrong here? Something bad is happening.
Excuse me, human teacher. The computer is quite correct.
Okay. I appear to have a computer virus.
How close we are to the sun has nothing to do with our seasons.
Really?
It's the axis, or the tilt of the planet, that gives us our seasons.
Huh?
Human teacher, please sit down so I can explain.
Okay. I'm already sitting, but sure, go ahead.
If you were to stand in front of this fire, would your back or front heat up faster?
Oh, my front would heat up. It'd get really hot, especially the fire that big. I mean, that'd be really hot, especially standing that close. Yeah, front of me would get really hot.
What if you turned around? What would happen to your front and back then?
Well, if I turned around, then my back would heat up, and I guess my front would cool off, right? Because it's facing away from the fire.
Exactly. Your back would heat up, and at the same time, your front
I'm
would
pretty
cool
good,
off.
aren't I?
With a fire this big, would it matter if you were here or here? Would it still be just as hot?
I'm thinking so. I mean, taking a step forward isn't going to really change a whole lot, right?
The Earth is sitting in front of a giant flame as well. We call it the Sun.
Yes.
As the Earth rotates, the side facing the Sun heats up, and the side facing away cools off.
That makes sense. So the side of the planet that's facing the sun is heating up. And the side of the planet facing away, the dark side, the night side, it gets cooler, right? Because it gets hot during the day, it gets cooler at night.
But of course, the Earth doesn't rotate this way, does it? It rotates on an axis.
Yeah. It rotates on its axis. That's right. We just talked about that. 23 degrees, remember?
Notice how the South Pole is constantly facing the fire, and the North Pole is constantly facing away.
Well, yeah, with the South Pole facing the fire like that, that South Pole is going to get all the heat, but the North Pole, it's facing away from the sun entirely. So I'm thinking it's not going to get any heat, if any at all, right?
The North Pole will not receive any of the sun's light or heat.
That makes sense. Yeah.
By contrast, the South Pole will receive total light and heat all day and night.
Whoa. So like it'll be like 3 o'clock in the morning and the sun will still be up in the South Pole. That's crazy.
The Earth is being heated unevenly. This happens every day of the year.
Oh, wow. That's kind of cool.
It is the uneven heating of the Earth that gives us our seasons.
That makes total sense.
When one of the Earth's poles faces the sun, it is summer in that hemisphere.
Okay, so you can see here that this is the North Pole, and the North Pole is facing, well, our computer virus Hal here, it's facing Hal, who I'm assuming is the sun right now, and it's getting really hot here, right? Because it's facing the sun, and it's not getting dark at all. So this is summertime, when our days are longer, right?
When the other pole is pointed away from the sun, it is winter in that hemisphere.
Oh, so when the pole is facing away from the sun, it's going to be wintertime because it's not going to get any light whatsoever. Oh, thank you so much. Okay, well, it appears my virus is going to go away. So this makes total sense if you think about it. If I'm standing in front of that giant fire and I'm facing that fire, I'm going to get really hot. And if I'm turned towards that fire, the top of me is going to get really hot. But my feet, because they're pointed away from the fire, they're going to get really cold. And this is what happens on planet Earth every year. As we go around the sun, our axis points in different directions. And this is what causes our seasons. So right here you can see, because the North Pole is facing the sun, it's getting all the sunlight. In fact, in the North Pole, it's not going to get dark at all. It's going to be 24 hours a day of sunlight. But at the South Pole, down here, it's pointed away from the sun entirely. So it's not going to get any light whatsoever. It's going to be dark 24 hours a day. That makes it really cold. And that's why we have winter on one side of the planet, the bottom side, and summer on the top of the planet. Now, 6 months later, the opposite is true. It's winter in the north because look here, the pole, it's facing away from the sun. The sun's rays are coming right here and they're stopping. It's not getting any light whatsoever at the North Pole, but the South Pole, it's getting all the light. No matter where this planet spins, it's still shining, the sun is still shining on the South Pole, right? So even though technically the Earth is closer to the sun during the winter time, during the summertime, I can read really. Even though the Earth is closer to the sun during the northern winter, it doesn't matter, as the North Pole is facing away from the sun and it doesn't get any heat. So we are a little bit closer by a few 100,000 miles or so. Not much. 10,000 miles or so. The distance that we wobble in our orbit isn't enough to really make the planet hotter or colder. What matters is the direction of our poles and what pole is facing the sun. Here in summer, this pole is facing the sun. Here in our winter, we're facing away from the sun, but the southern hemisphere is facing the sun. So now the southern hemisphere has their summer while we're freezing in the north. 2 times a year, the poles receive 24 hours of total light or total darkness. So this is called the summer or winter solstice. The solstice marks the beginning of either the summer or the winter seasons. The summer season, summer solstice for the northern hemisphere, winter solstice for the southern hemisphere. This is the longest day of the year for the northern hemisphere. It is the shortest day of the year in the winter, or in the southern hemisphere for winter. The northern hemisphere in the wintertime, pointed away, is the shortest day of the year for the north, and vice versa, the longest day of the year for the south, their summer solstice. So while we're up here in the north freezing to death, in the south, they are nice and warm.
Okay, we know.
You're back. So we know where the summer and winter are. Which one is the spring and fall? Well, let's see. We've been going around the sun this way, right? So if I'm traveling this way and this is summer, and I'm going this way, and winter's over here, this is going to be the, that's right, Dora, that's going to be the fall. So summer, fall, winter, what comes after winter? Yes, Dora, the spring. Very good.
Correct.
Yes!
You're pretty smart. We're humans.
Thank you, Hal. These 2 points of the year mark the beginning of the spring and fall seasons. They are known as the equinox. On the equinox, the Earth receives 12 hours of day and 12 hours of night at both poles. So it's perfectly split in half. Our sun, right here in the middle, the Earth facing the sun, the entire planet, north and south, gets the same amount of light. Same down here in the spring. The whole planet gets an equal amount of sun all day, all night, 12 hours. Make sense? The spring is called the vernal equinox. Like green, vernal. The fall is called the autumnal equinox, as in autumn. Yeah, I know, right?
Observe, tiny humans. Look at how the light shifts across the planet over the course of a year.
Okay, this is actually pretty cool. This is a satellite composite image, meaning it took one picture of the planet Earth every day for 365 days. This line going up and down the planet right here, they call this the Terminator. I'll be back. No, different one. This is the line, the Terminator line, between the day side and the dark side, the night side. Okay? And this is the line that they call the line of the Terminator, which is sunset or sunrise, depending on which side of the rotation you're on, I guess. Yeah. And what's really fascinating about this is to watch the light travel and shift across the planet. Right here, this is summer. This is the summer solstice. The North Pole is right here. And as the Earth spins, it's not going to get any darkness whatsoever. It's going to be totally light. And if we go straight down to the bottom, there's the South Pole. No matter how the Earth spins, it's not getting any light whatsoever. So it's totally dark there, 24 hours a day during the winter months. Right? So as we go around the sun, the angle of our planet angles different directions as we go around. And sometimes we're pointed away, sometimes we're straight up and down like now, and sometimes we're pointed the wrong direction and it's wintertime. So right here, this is the equinox, give or take a day or two. Okay? Equal light across the planet. One half light, the other half dark, and the line straight up and down on our axis. Now, as we progress, this is the summer solstice, and it comes back. This is the fall or autumnal equinox. And now it's December, and this is the winter solstice, yeah. And it goes back and forth. It's hypnotic, isn't it? Wow, man. Okay. Oops. It is quiz time. Here's what I want you to do. Looking on the other side of your note sheets, you have a little quiz to take. And the first thing I want you to do is answer the following questions. And these are written on your sheet. I want you to tell me the Earth's North Pole is closer to the sun in the what part of the year? What season? And what causes the change of seasons here on Earth? Look at your notes. And then, if the Earth is moving around the sun in a clockwise direction, meaning from A to B to C to D and back to A this way, label each of the seasons for the North Pole. And I'll give you a hint. Look at the poles. Which one is facing the sun? Totally, no dark. This is the dark, this is the light. Which one's getting all the light? Which one's getting all the darkness? All the light gets all the heat. That's summer. All the darkness, no heat. Yes, that's winter. Go ahead, push pause right here and go ahead and take your quiz and hit start again after you're done. Okay, so I'm going to assume that you are now done with your quiz. And let's take a look at the answer, shall we? To begin with, the Earth's North Pole is closer to the sun in the winter or summer. Yes, it is in the wintertime. We are closer to the sun in the winter in the northern hemisphere. It's crazy, but it's true. When the pole faces the sun, it is summer, even though the North Pole is closer to the sun in the winter. It is facing away from the sun, so we don't get its light and heat, even though we're a little closer to the sun. What causes the change of seasons? One word and one word only. Starts with an A, rhymes with axis. Yes, the axial tilt of the planet or its axis. Okay, so if we look at our diagram here, we are orbiting in a clockwise direction, meaning we're going from A to B to C to D. So starting here at A, this line is the North Pole, and it is facing away from the sun. It's totally dark right here. No sun is shining. Therefore, that makes it the winter. So A is the winter solstice. B, well, we're going this way. What comes after winter? Spring. So B is spring. That means summer, pointed totally to the sun, getting all the heat, summer. And what comes after summer but the fall, which brings us back to A, winter. Great job, everybody. If you need to replay any of this to fill in your blanks, please do so. We will be looking. And I hope you did well and that you understand. If you have any questions, feel free to ask your teacher when you meet back again. We'll see you soon. Thank you, everybody.